Hi Navdeep, how are you? I'm just waiting for Melissa to join. It looks like she might be having some problems joining, connecting to audio. I'll just give Melissa a minute here. Melissa, can you hear us? Are you still at the college, Navdeep?
Yes, Stewart.
You are, right? Working hard, I hope, right?
Yeah, actually, I have a shift today, and on 5 p.m. I
Oh yeah,
go to my restaurant.
oh yeah,
I'm directly here, yes.
yeah.
So that is why my work is near from the college, so I can stay here.
Where do you work?
Restaurant.
Where's that?
Restaurant.
Oh, a restaurant, one that's close to the college, is it?
Yes.
Yeah. Okay, I'm not sure what. I'm not sure what.
And also,
Oh,
Stewart,
hold on. Yeah.
in the written description of investigation, we have to include the detail of every borehole because it's too lengthy if we include the every borehole detail.
Yeah, no, you don't have to include every borehole.
Okay,
You just do a very brief summary.
okay.
Yeah. Hi, Melissa, how are you?
Good. Sorry, I got really into my phase one assessment. So
That's okay. Yeah, it looked like you were having trouble connecting. So I actually sent you a new copy of that PDF file that actually works, right? But
perfect.
Navdeep, I put a topographic map of
Yes.
Durham College into DC Connect, right? And here I'm just going to quickly bring it up, right? So this is the Durham College topographic map that I put in there. So I had some questions asked about, how do you interpret these maps? So I thought what I would do is I would just kind of walk through with you guys what we do with the topographic maps, and also there's a map in there for the depth to bedrock at the college, right? So you guys stop me at any time if you have a question, right? But this is the topographic map as it was downloaded from the Ministry of Natural Resources, right? So it's got all the copyright information down in the bottom of it, and you can just refer to the Ministry of Natural Resources and Forests Make a Map website as to where you got it from, right? But essentially, what we do with these, right, is we download this map as a PDF, and we can include this PDF version in the report, or we can actually do some work on it, right? But I just wanted to take a quick look at what it is that these topographic maps are telling us, right? So if you look at this is Durham College building, right? This is the Gordon Wiley building that you guys are doing the phase one on, right? And there's three key pieces of information here. If you look here, I've circled this 150, right? And I've pointed the arrow right at this line. So essentially, this line that moves down through here shows a ground elevation where it's at 150 meters. So we can tell from this that the site that the college is on is pretty flat, right? It's flat and it has a an elevation of 150 meters, right? So that's one piece of information. But if we look at these other lines, see this one I've circled here, it says 145. And this one, it's almost off the bottom, but we can see it up here as well. It says 140. So what we can tell from this is the college site is essentially flat, but it does begin to slope, and it slopes, there's a slope of about 10 meters from where the college is down to the creek, which is right here, right? So, and we know that because every time we walk down here, we go down that really steep embankment to get to the creek, right? So we don't know enough in a phase 1 environmental site assessment to say where is groundwater flowing, right? But we can make an interpretation of where it's flowing from this map, right? So we have the map. I'm going to show you the second thing that we can tell from it. So north is straight up and down, but if you look at this, if you draw a line, I'm not sure if I can actually draw on this anymore, but anyway, if you draw a line along this topographic line here, and you draw a line at a right angle to that line, that is a pretty good indicator of the direction of groundwater flow, because groundwater is going to, generally speaking, follow the topography of the land, right? So you can draw a line here, a 90-degree angle. You can draw a line from this topographic line. So find the section that's straight, draw 90 degrees off it. Same up here. So you can tell that essentially the inferred groundwater flow direction is going to be from the college in a southwest direction. This one is a bit tougher, because if you were to draw a line 90 degrees off, you get a groundwater flow direction in here, but it's really flat. And essentially what groundwater would do is it would tend to curve, and then it would begin to follow these lines, right? So the information that you've got from this is that you can say that the college site is generally flat with an elevation of 150 meters. The topography of the site slopes to the southwest with a total relief of approximately 40 meters from the college building. 10 meters from the college building to the creek. That's called the relief. That's the difference in elevation. So there's a total relief of approximately 10 meters to the creek, and that based on the topographic map, you can say that you are inferring the groundwater flow direction to follow the topographic lines, and you would do a drawing very similar to this, and you would include it in your phase 1 report. So Melissa and Navdeep, do you have any questions about that? Does that make sense to you guys?
Yes.
Yes,
Yeah.
it makes sense.
It makes sense, right? So when I say that the college has an elevation of 150 meters, there's an important thing that you have to put after that in your report. Any idea what that is?
From sea level?
Right. So you would write that the college site has, it's essentially flat with an elevation of 150 meters above mean sea level, right? Because obviously sea level changes fluctuates with tides, right?
Right.
So they have a mean elevation that they have set at 0. So this point on the college property is 150 meters above mean sea level. Right. Now, what I want to quickly show you guys as well is I just want to kind of show you what we do with these if I can quickly find one. If I can quickly find one that I can show you. I'm quickly going through my our files to see if see if I can find one. And would you know it, I'm having trouble actually finding one. Just bear with me just for 1 minute here. I think this may be the easiest way to find it right here. So this one is, I'm just going to stop sharing for a second and then I'm going to reshare. So this one's a little different. We probably didn't have a very good topographic map that we could bring in, but we, in the case where we have a topographic map, we would bring the actual topographic map in and see these blue arrows that we put on here. These are, as you can see down here in the below the image, we've included a blue arrow that shows, and it says inferred groundwater flow direction. Okay, so if I was you guys and you were going to create your own figure to include in the report, I would try and bring in the JPEG image from that map from the MNR site, and you would create some kind of arrows. They don't have to be like this. That just shows the inferred groundwater flow direction. And as you can see at the bottom of our figure, we've referenced where the source drawing came from. So here's another thing that I just want to quickly talk to you about. Let me just quickly share this. So if you were to use this in one of your figures, what is the scale of this drawing? Do we know what the scale of that drawing is?
No, we do not.
We do not, right? Because if we go back to the PDF, right? Can you see my PDF now?
No.
Yeah, see, bloody Zoom, eh? Okay. If we go back to the PDF, it has a scale on it, right?
Mm-hmm.
But if we're just going to use the JPEG image, there is no scale, right? So what we do in a situation like that is that we clearly on the figure that we do, we have is, see here, it says scale as shown because it's got the scale bar here, right? And if there's no scale bar and you don't know 100% what the scale is, you should indicate scale NTS, which is the generally accepted acronym for not to scale.
Okay.
Right, because we don't know what the scale is, right? Right.
Right.
So okay, so is that helpful as far as the topographic mapping goes?
Yes.
Yes,
Very
Stuart.
helpful.
Yeah. Okay. Do you want to take a quick? Want me to take a quick look at the bedrock?
Yes, please.
Okay. So let's just quickly
Stuart,
bring. Yes.
my bus is coming, so I will
Yep.
leave, and it's for my clear.
Yep. No, that's good. I'll send you a recording of this.
Oh,
Okay.
thank you so much. Okay,
Okay.
Stuart, bye.
Okay.
Bye.
Bye.
Take care.
Okay. Bye. Yeah. Let me just quickly share this again. Okay, so here is our bedrock map, right? So you can see this. This is essentially has the same thing. It has a whole series of contours. right? The same as what surface topography has, right? But if you look over at the scale over on the side, it tells you something about what the symbols are, right? This one, the line with the 90 in it, is the inferred bedrock contour with 10 meter intervals, right? If it has a black dot, it's the elevation of the bedrock surface in a water well. If it has an X, it's the elevation of a bedrock outcrop in meters, right? So
Okay.
what did we decide from our topographic map that the elevation of the college was?
150.
Was it 150? Okay,
Yeah.
so if we zoom in on this, let me move this out of my way. If we zoom in on this, all right, this very handily tells us Durham College is right here, right?
Yep.
Right. So see this contour here?
Mm-hmm.
It means that it's telling us that the bedrock is at an elevation of 110 meters. Here, the elevation is at 100 meters.
Okay.
But interestingly, see this black dot?
Yeah, that's the well, right?
That is a well. So at one point in time, there was a well in Durham College's property, right? I don't, and that might actually be interesting for you to point out when if you're doing a brief description of this. It's just to say that the drawing does show a well on Durham College's property, right? So we can tell with a great degree of accuracy, right? If that well wasn't there, all we could say is it's somewhat between 101 and 110 meters elevation, but we know that there's a well right here on the property, and the bedrock is 102 meters at an elevation of 102 meters. So how much, do you know what overburden means?
No.
So overburden is the soil that sits above bedrock. So what is our overburden thickness at the college?
The soil that sits above bedrock, would it be 8?
No, so we got 150. The elevation of the
Oh,
right?
so that's 48 then, wouldn't
48.
it?
So we can tell from this drawing, and it would be. I mean, that's an interesting thing to point out in your phase one, right? Is that at the college there is approximately 48 meters of overburden above the bedrock. So yeah, so in southern Ontario, you always find the bedrock is decreasing as we get closer to Lake Ontario, right?
Okay.
So it's actually sloping to the south as well. But I just one other thing I want to show you in case you ever have to interpret one of these. See how these X83,
Yeah.
X83, the X means a bedrock outcrop. So do you know what a bedrock outcrop means?
No.
So if you see anything referring to a bedrock outcrop, it means that there's no soil above it.
Oh,
And
so
if you-
that's just basic. That's just
So,
basic
yeah,
bedrock.
right. So
Okay.
if you look at this, see how there's a creek coming through here?
Yeah.
That's the Lynn Creek. So there's two areas in the Lynn Creek where it has eroded right down to bedrock.
Oh, wow.
And that bedrock is sitting at 83 meters.
Okay.
Right. So there is no overburdening in this area, right?
Yeah.
Right. So I just wanted to point that out to you, right? So there's a couple of really key pieces of information from this bedrock map, is that you can tell that there was a well on Durham College's property at one time.
Yep.
Right.
And it's at 102.
And the bedrock elevation is at 102, and again that's above. So how I told you should say that the elevation of the college is at 150 meters above mean sea level.
Mm-hmm.
In the report, the first time you say that, you would type out above mean sea level.
Okay.
But then every time afterwards, you would just put AMSL.
Oh, okay.
Right? So you would type it out, put it in brackets after it, AMSL, close the bracket, and then from there on in, you would only use AMSL.
Okay.
Okay. All right. So is that helpful?
Yes.
Yeah. Okay. Do you have any questions about any of it?